So welcome back to everyone, and today we are going to start our topic. Okay, so we have already uh, discussed what is NumPy and Pandas. Okay, so those are the data analysis libraries. Okay, so we can make data analysis charts and data frames. Okay, using Pandas and NumPys, right? And today we're gonna see one more library for visualization, that is Matplotlib. Okay, so the Matplotlib is used for creating a charts. Okay, creating a by chart, bar chart, and some graphs. Okay, so today we'll see what is Matplotlib and we'll see some examples on that. Okay, so a Matplotlib. So Matplotlib is the grandfather library of data visualization. The visualization is nothing but it's like making a graphs. Okay, so that is called visualization, right? So Matplotlib is the grandfather library of data visualization with Python. Okay, so it was created by John Hunter. Okay, he is the creator of Matplotlib library, and he created it to try to replicate MATLABs. Okay, so MATLABs is for matrix laboratory. Okay, so MATLAB stands for matrix laboratory. We can make programs, we can connect the blocks. Okay, so we can solve the mathematical equations by real life. Okay, so you can imagine and you can figure it out, the Fourier transform and some of the companies using MATLAB to get or solve their equations by using MATLAB. Okay, the MATLAB stands for Matrix Laboratory, and there is another programming language. So plotting capabilities in Python. So if you happen to be familiar with MATLAB, okay, so Matplotlib will feel natural to you. So if you are familiar in MATLAB, Matplotlib is same as your MATLAB. Okay, so if you are in engineering background or BE background, okay, so everyone have labs on MATLAB, okay, practical sessions MATLAB in your first year and second year. If not, so don't worry, MATLAB is a matrix laboratory and it used to create or solve your equations and make some equations output and like, yeah, that's all. So the equations we can solve by using MATLAB. Okay, so the Matplotlib is an excellent 2D and 3D graphics library for generating scientific figures. Okay, some of the major purpose of Matplotlib are generally easy to get started for simple plots, support for custom labels and text. Okay, so great control of every element in a figure and high quality output in many formats, very customizable in general. Okay, so these are the pros of your Matplotlib. Okay, so Matplotlib allows you to create a reproducible figures from programmatically. Okay, so let's learn how to use it before continuing this lecture. So we have one link matplotlib.org. Okay, so and the link is for Matplot library, and the web page has everything about Matplotlib. If you want to know what are the figures or what are the types of figures in Matplotlib, you can use matplotlib.org. Okay, so the website has figure programming also. Okay, so if once again it's loading. Okay, so it shows lot of figure examples. Even pie chart, we have lot of examples. Okay, we have lot of examples in matplotlib.org website, and you can get the code for each pie plot and each example program for each pie plot. Okay, and this is the Matplotlib library home page. Okay, so you have tutorials, examples, and documentation. Okay, navigation bar, and you can also learn Matplotlib clearly by using this. Okay, so this is the gallery. We have lot of types. Okay, so stacked bar chart and grouped bar chart, these are the types of bar charts. Okay, so horizontal bar charts, broken bar charts, and this is curve with error bond. Okay, these are the types of graphs. Okay, so this is hatch filled histograms. Okay, so if you want to know the coding behind it, you can just click the figure. Okay, so these are the types. We have lot of types, statisticals and pie charts. Okay, so in even pie chart we have lot of type. Okay, so I'm clicking this, it gives error. Okay, so you can get the code by clicking. So it gives an error for because I am using Kaspersky, that's why it gives error. Okay, so you can access this by clicking the figure. Okay, you can get the codes. So you have also the tutorials, examples, and documentation. Okay, how to install the Matplotlib. Okay, so check it out, guys, and so back to the topic. So installation. Okay, so you can use Conda install Matplotlib, or a better choice is go to your command prompt and type pip install Matplotlib. Okay, that's a no. So it will install your Matplot library. Okay, so here we have to import like this because we are using pyplot in the matplot library. Okay, so we have to import like this, import matplotlib.pyplot. Okay, so we are going to do some examples in pyplot. That's why I'm giving like this, import matplotlib.pyplot as plt for alias name. Okay, and so you will also need to use the line see plots in the notebook. If you are using Jupyter notebook, give percentage matplotlib inline. Okay, so if you are not using Jupyter, okay, if you are using another ID is, you have to give plt because plt is my alias name. Okay, so you have to give plt dot show for seeing your plots. Okay, if you are giving percentage matplotlib inline, it shows your figure inside your Jupyter notebook. Okay, or you can use plt.show for seeing your plotting figures. Okay, and the basic example. Okay, so here I'm using linspace. Okay, so linspace means that's a line space, that's all. This is your starting value and this is your ending value. 0 is your starting and 5 is your ending value. Okay, and here, so both are inclusive. Okay, so if you are taking range function and the starting value is inclusive and the ending value is exclusive, right? So here the both are inclusive, and if you are giving level, the level is used to separate 11 parts from 0 to 5. Okay, that is the linspace. Okay, so if you are giving 10, it separates the value 0 from 5 with 10 parts. Okay, here we have 11 values. Okay, so that is the linspace, and here I'm gonna create using np, that's a numpy, x equal to np dot linspace 0 comma 5 comma 11. Okay, we have 11 values in there, and here y equal to x double star 2. Just I am getting square of x value then stored into y. Okay, so now x has 0, 0 0.5, 1, 1.5 some values, and y has the squared version of x. Okay, so now we have two values, two array values, or two array values. Okay, so the basic matplotlib commands. Okay, so plt dot plot, if you are giving plt dot plot x comma y, okay, those are the values. For x is for x left side, okay, that's a horizontal one. Sorry, x is for horizontal one, that is your bottom line. Okay, and the y is for the second position. Okay, so you can interchange. Okay, you can give y for front and x for second one. Okay, so the syntax is, first is your x value, and second is your y value, and third is your color. Okay, so you can see here, so we have x values from 0 to 25. Okay, so and the y values, sorry, x value from 0 to 5, right? Because we have 0 to 5, that's the x value, and we have 0 to 25, that's a y value. That's why it gives like this. Okay, so here I'm going to change my x in here and y in here. Okay, I'm going to run this. First, I need to run this one, then this, and then this, and then. Finally, so I'm going to run this. Okay, you can see the plot has changed. Okay, so the syntax is, first is your x value and the second is your y value. Okay, so you can give what value you want to place it in your x side and y side. Okay, here I have changed 25 is my x value and 5 for y value. Okay, that's all. Our basic plot is ready now. Okay, the next one, so this is your color, right? I'm giving B, your color changed into B. Okay, so the method is called functional type. Okay, the method is called function type. If you are calling plt.plot, the method is called functional type. Okay, and here x label for x heading here. Okay, so x label for x heading and y label for y heading. Okay, and the title for your plot title. Okay, so you can give plt is my matplotlib dot pyplot, right? And plt dot x label, you can pass your heading here or title here, and y label, you can pass your y label title here. Okay, the title, and the title is for your entire chart. Okay, then finally you have to give plt dot show. Okay, this is your functional type. Is it clear?
Yes, sir.
Yeah, so next, okay, so here this is your canvas, right? So this is your portion, or this is your figure, right? So the next step is, we are going to create multiple number of plots in this canvas. Okay, the canvas means it's like a box. Okay, it's or a boundary. Okay, and here, so if you want to create two or more plots in a single area, okay, you have to give plt dot subplots instead of plot. If you want to create a plot, one plot, you have to give plot in here. Okay, plt dot plot. If you want to create two or more, you have to use subplots. Okay, you can see plt dot subplot. Okay, so the first value is for rows. Okay, so rows, and the second value is for column, and the third value is for plot number. Okay, so in first we are going to give two rows, and the column is 2 and the plot number is 2. Okay, so here we get two rows and two columns. Okay, so the first one is red, right? So red is this value because we are choosing second one, right? So the plot number is second one because we have it's like your data frame. Okay, so this is 2 cross 2, right? So 2 cross 2 means we get 4 values. Okay, so in here we get 4 plots. Okay, so if you are giving 1 cross 1, it gives 1 and 1, total 2. Sorry, total 1. If you are giving 2 cross 1, we get 2. If you are giving 2 cross 2, we get 4. Okay, so here I'm choosing second value. Okay, say I'm choosing plot number second. So the plt dot plot first plot. Okay, the plt dot plot first plot is in the second question. Okay, and here I mentioned the line format. Okay, I mentioned the line format. If you are giving double slash double hyphens here, it gives like this. Okay, and the second plot, and the second plot I have chosen first position. Okay, I'm going to change this one is in first and this one is two, second position. Now you can see, so I'm going to run this. The plot has changed, right? So now the red is in first place and green is in second place. Okay, so next, so and the second plot I'm choosing second. Okay, so plot number is second and it shows in second place. Okay, so if you want to create a single plot, you need to give plot, that's enough. If you want to create a subplot, you have to mention that. Okay, and after you have to pass your values. We have x value and y value, right? Okay, so if you don't want to create a subplot, you just mention plot dot plt dot plot and the parameters. If you want subplot, you have to mention it. Okay, then after you have to pass the values. Okay, and here we have the third one. Third one is I want to give star, and for star is for each value. Here you can count, and the each value is for values are 25, right? So here we have 25 values and star has placed as 25. Okay, and here you can use blue, green. Okay, I'm going to run this. You can see the color has changed, right? Okay, is it clear? Do you have any doubts in this portion, subplot?
Sir.
Okay, and the before steps are functional programming, because we are directly call the function, and we have developed a plot or plots. Okay, and the next one is object oriented method. The object oriented means the method is based on object in the sense, so it's maybe your computer or a figure or a box. Okay, that's an object, right? And so now that we have seen the basis, let's break it all down with a more formal introduction of Matplotlib, object-oriented APIs. Okay, this means we will figure object and then call methods for or attributes from the object. Okay, first we are going to make a figure. Okay, first we are going to make a figure in the sense means this is your figure, right? So the entire, like I'll show in here, and this is your figure. Okay, so first we will define the figure size and figure margins, then after that we're gonna use our methods. Okay, so introduction to object-oriented method. The main idea in using the more formal object-oriented method is to create figure objects and then just call methods or attributes of that object. Okay, so this approach is nicer when dealing with the canvas that has multiple plots on. Okay, here first you have to create a figure, that is empty canvas. Okay, canvas means it has boundaries, right? Okay, you need to create a figure by using plt.figure. That's all. Then after that you need to add an axis. Okay, so the axis for those are the values. Okay, so first left axis and bottom and width and height. Okay, so first one is left and second one is bottom and third one is width and fourth one is height. Okay, then finally you can give the, or you can pass the parameters same as we have done in functions. Okay, and in functions we are calling the plot and pass the xy function, right? And here in function programming we are calling the plot from plt. Okay, in here in object oriented programming, first we are calling plt.figure, then we are gonna make some axis in here, and after that we're gonna call dot plot in axis. Okay, that is the difference between your functional programming and object oriented. Okay, so first we create a canvas, after that the further process all are based in your canvas. Okay, so then here in functional programming we are just giving plt.x label, right? And here we need to give axis dot set underscore x label. That is the difference. Okay, here we are using set underscore etc. Okay, so set underscore x label, and here you have to give your name or title of your x label, and then here you have to mention your title of your y label, then title. Now you get the figure, right? Is it clear? Do you have any doubts on this block?
No, sir.
Yeah, sure.
Yes, sir.
And the next one, so we are going to create two plots in single figure. Okay, so two plots in single figure, right? So first you need to create a canvas, right? You have to mention equal to plt dot figure. Then after that, in the above one, we just declare only one variable, right? And here you need to create a two variable, because we are going to create a two plots, right? First you have to mention this is for left and this one is for right, and this one is for height, and this one is for width. Okay, So in first plot, we are giving 1188. Okay, so the values should be in 0 to 1. Okay, so 0.1 is for 1% and 0.8 for, it's like a 10%, sorry, 0.1 for 10% and 0.8 for 80%. Okay, the value should be in 0 to 1. Okay, so this is your main axis and this is your main axis, and here the value has changed a little bit, right? Okay, so if you are changing this value and the plot, so the left and bottom is moves, okay, moving to some other place. Okay, so if you are, it's like this. Okay, so here we have given 0.2 and 0.5 and the left bottom is, you can see my cursor. Okay, and it moves from here to there. Okay, and the length and height we are giving with this, sorry, width and height. Okay, so both are same, right? Okay, 0.5 is your width and 0.3 is for your height. Okay, this is your height and this is your width. Okay, then we need to mention those axis variables separately. Okay, first we need to pass the parameter for main axis, that is axis 1. Here I'm going to give plot x comma y and the axis color is blue. That's why I'm giving B, and the x label, y label, then title. So same as the axis plot is y comma x. Okay, so I have changed the value in here. Okay, so in the above one, x comma y, and here y comma x. Okay, and after that I have set x label and y label title. Okay, so we get the figure like this. Okay, so then I'm going to change my length. Okay, so I'm going to give 3 here. So I'm going to run this. You can get the figure like this. Okay, so if you are giving 5, the figure goes into here, right? So here I have given 3. Okay, 3 plus 3 is a square one, right? So that's why we get the value, we get the plot like this. Okay, this is your inside plot. Okay, so this is your inside one and this is your outside one. Okay, so we can create a plot like this, right? Is it clear? Do you have any doubts?
No, sir.
Yeah, sure. And the next, so in the functional programming, we have seen how to plot a subplots, right? Okay, in our OOP, we also have subplots. Okay, and this is different one. Okay, so we are plotting the figure inside. Okay, we are plotting the figure with inside one, right? So then after we have subplots. Subplot means we can give 2 or more plots with the same parameters in that canvas. Okay, so subplots, and first you need to create a subplots instead of figure. You have to create a subplots. Okay, so here I'm using some tuple unpacking. Okay, so here I'm going to save this plot into 2 variables. Okay, so you can use comma for separating that variable. You can save those values into fig and axis. Okay, then after that, so I'm gonna create the axis plot. Okay, so axis plot like x comma y, or and set x label, y label. Okay, so you get plot like this, right? Then after I'm gonna give, okay, fig and axis in here. Okay, so I'm gonna give fig and axis, rows and columns, same as your function one. Okay, and here we are giving row 1 and column 2. Okay, so this is row and column. So we get two plots in single row. Then after that, so your axis look like list. Okay, so this all the object for each plot. Okay, this one is for first one and this one is for second. Okay, so you can, if you can iterate them, right? Because we have list value with the two elements, you can access the each element by using for loop. Okay, so here I'm going to give for ax in axis. Axis has two functions or two graphs, right? So if you are giving for ax in axis, then you can pass ax dot plot. Okay, and x y, then color is blue. And here I'm going to give just label is x and label is y and type. Okay, so it returns those values. Okay, in first, because we have two values and it runs two times, right? So in the first time, the value applies in first one, and the second time the values applies in second. Okay, so that's how we get this two plots with same parameter. Okay, and here you can see it's just overlapping the another one, right? Okay, we have an option to give a space, even space between those plots. Okay, that is type plot. Okay, if you are giving plt dot type underscore layout after your for loop. Okay, plot plt dot type underscore layout, it looks like this. Okay, you can see the y is overlapping the first one, right? And here you can see the plots are evenly spaced. If you are using type underscore layout, it shows like this. Okay, and then so we have seen how to give an axis, the axis for moving your plot. Okay, so, like this. Okay, so if you want to move and give size for reducing your length and width. Okay, so you can give here, right? If you want to zoom and zoom out, or if you want to create a DPI means dot per inch. Okay, dot per inch, this is the resolution. Okay, the resolution for your image. This is an image, right? Okay, so here the Matplotlib allows the aspect ratio of DPI. DPI means dot per inch. Okay, so your monitors are based on dot matrix. Okay, and even your this fonts also based on dots. Okay, so the R is collection of so many dots, right? Okay, this that is DPI. Okay, so DPI is mentioned is the resolution of your figure. Okay, and DPI and the figure size. Figure size means overall size. Okay, so to be specified when the figure object is created, you can use the fixed size and DPI keywords. Okay, so the fixed size is a tuple of the width and height. Okay, so the axis is different. Okay, so here be aware of that. So the add axis is different. Axis means when or where your plot is placed in that canvas. Okay, that is axis. Okay, that is axis, and the fixed size is for overall size for your image. Okay, so then you can give while creating your figure, while creating your canvas. Okay, fig equal to plt dot figure, and fixed size is you have to mention in tuple. Okay, so first is for 8 is for length, sorry, width, and 4 is for height. Okay, and dpa is no need to specify that, because in default the dpa equal to 100. If you want to improve that size, you need to specify one. Okay, then okay, so here you can see, so we are giving the fixed size because you no need to specify this if you want to print 100 resolution. Okay, if you want to print 200 or 300, you have to specify. Okay, in default value it takes 100. Okay, so that's why I'm not specifying here. Okay, so just you have to give fixed size equal to 12,5. After that, so that's a figure, right? You have to pass your parameter axis dot plot x comma y. The color is or red. Okay, then after that I'm going to give like slashes, sorry, hyphens, and after that I want to set my x and y title, then title. That's all. I'm going to run this. So it gives hyphen like this. Okay, so if you're giving dot, it gives dots, and if you're giving star here or ash here, so it gives error. Okay, so you have to mention star or hyphens. Okay, I'm gonna give star here, it gives star like this. Okay, so the size is based on your width and height. If I reduce the width, it gives like this. Okay, is it clear?
Yes, sir.
Yeah. And the final one is, so you have created a plots, right? The last one is you have to save it, right? Okay, we have to save the file, right? So we have a method that is fit.savefit. Okay, and here just mention the file name, then the format. Okay, if you want to get JPEG, you have to mention JPG. What the format you want, you can mention it here. If you want to get IOC, you can give IOC here. IOC is for icon file. Okay, so PNG and JPEG, then GIF, what extension you want, you can give here, and it simply saves your file in PNG or JPEG or GIF, what you are giving here, right? And you can also mention the DPI. If you are not mentioning the DPI, it takes your DPI from the creation in here. Okay, so otherwise, if you want to get, if you want to save the file in your particular ratio, you have to mention it. Okay, I'm going to run this. You can also specify the path you want. I'm going to run this. Okay, now I'm going to check my path. Okay, you can see here file name.png, it's saved. Okay, you can create the plots, and you can also save the plots in what format you want, right? Right, then, and then the next topic we are going to see legends, labels, and titles. Okay, so what is legends, labels, and titles? We know what is labels and what is titles, right? What is legends? Okay, so So DPI is for a resolution. Okay, you have mentioned the pixel size, right? So if you are downloading the images from your website or whatever the website, okay. So if the pixel size reduces, your image quality reduce, right? So that is DPI. If you are giving DPI equal to small value, then your image is look like small. Okay. If you are giving DPI equal to higher value, and your image it is in higher quality. Okay. So the DPI is based on quality and the pixel size. Okay.
Okay, sir.
Yeah. Okay, so first figure titles. You can give the figure title. Okay, so a title can be added to each axis instance in a figure. To set the title, use the set title method. Okay, so axis labels. So labels is the same as set underscore x label and set underscore y label. That's all. What is legends? Okay, so legends are, you can use the label equal to label text keyword argument when plots or other objects are added to the figure, and then using the legend method without arguments to add the legend to the figure. Okay, so it means you have, yeah.
Screen share.
Oh, sorry. Yeah, sure. And here I have created two plots. Okay, so you can give like this, and you can create two lines in single plot. Okay, so first I have mentioned fig equal to plt dot figure. Then after that I have created an axis for that figure. Then I have mentioned, or I have passed the parameters. First I have passed x and comma the square value of x. Then after that I have mentioned the cubed value of x. Okay, so both are different values, right? You have to mention the label for each line of your graph. Okay, so here we have red one and blue one, right? So if you want to specify, or we have more number of lines in single plot, okay, we don't know what is, okay, so we have to mention it, right? If you want to point out a single line, you have to mention, or you have to name that line. Okay, the legend is for taking the labels, and the 4 is for location. Okay, the 4 is for location. Okay, if you are giving 0 and it finds best location, if you are giving 4 and it's left down position. Okay, so in each number we have the position value. Okay, so simply you have to mention 0. Okay, so 0 is for best. Okay, so the best is finding where the empty place it is in your figure. We have empty place in here and empty place in here. Okay, if you do not give LOC value, and it may be the x and y values are in here. Okay, it's overlapping your lines. Okay, so we have to mention 0 in here. Okay, 0 is for best position. Okay, and it finds the best position of your figure. Okay, so it finds the empty position of your figure. We have empty positions on here and here, and it simply place this square into that location. Okay, so if you are giving legend, you have to mention the label. Okay, so the label is for first one and this label is for second one. Okay, so I have changed the LOC equal to 0. Okay, you can see it takes the best place of your figure. Okay, this is your best place, right? Because we can see clearly in here. Okay, in first the label is in here, right? And if you are giving 3 and your figure is in here, okay, it overlaps your line. Okay, so 0 is for best. Okay, 0 is automatically finds your best position. Okay, 0 means best. Okay, so keep remember the 0 is best. Okay, so that's all. Legend is used to labeling your graph lines. Okay, legend is used to labeling your graph lines. That's all. Okay, so I'm gonna create one more line here. So I'm gonna give a double star R here. Here I'm gonna give Y. Okay, so we have value in Y, right? I'm gonna run this. You have 3 values. Okay, so it shows 2 X plot and yeah, I'm gonna change this into Y. And blue. I'm going to remove this. Now you can see the 2 values because X is not taking. The reason is we have X, X, X. Okay. Then label is Y. Okay. Okay, I'm going to remove this one. So now we get 2 values. One is for Y and another one is for X. Okay. So in future, we will see how to give 2 or more rows in single figure. Okay. Now we have created 2 lines. Okay, 2 graphs lines in single one. I have given Y in here and also X in here. Okay. So the legend is used to locate and labeling your lines. If you are removing legend, it's like it won't show. Okay, if you are giving legend here and it shows your labels. Okay, is it clear? Do you have any doubts?
No, sir.
Yeah.
No, sir.
Okay. Okay, these are the explanations for the number you have. We are used in a legend LOC. Okay, so 0 is for
Base.
0 is for best and
Okay.
1 is for upper right and 2 is for upper left and 3 is for left corner and 4 is for right corner. Okay, yeah. Then if you are giving Z and the Matplotlib decide the optimal, that means best location in your figure. That's all. Okay. And the next one is setting colors and line width and line types. Okay. So Matplotlib gives you a lot of options for customizing colors, line width and line types. Okay. That is the basic MATLAB like syntax which I would suggest you to avoid using for more clarity sake of this. Okay. So it's look like your Matplotlib. If you are already knowing Matplotlib, you can easily understand what what are the colors we are going to use here. Okay, so colors with Matplotlib like syntax. Okay, so with Matplotlib we can define the colors of lines and other graphical elements in a number of ways. First of all, we can use the Matplotlib like syntax where B means blue and G means green and etc. Okay, the MATLAB API, okay, MATLAB is different programming one, and for selecting lines are also supported. Where, for example, B dot hyphen, and it gives blue line with dots, blue line with dots. Okay, so we'll see. Here, I'm gonna create a subplot. Okay, so plt dot subplots, and I'm going to pass two plots in here. One is for B and another is for green. That is blue one and green one. Okay. So blue I have mentioned dot. Okay. Dot hyphens. Okay. Then green I have mentioned dashes. Okay. You can see. And the green is for dashes lines, and the blue is for one dot and line, dot and line, dot and line. Okay. Then, so colors with colors equal to parameter. So we can also define colors by their names or RGB hexa codes, and optionally provide an alpha value using the color. And alpha keyword arguments, alpha indicates opacity. Opacity means we can adjust the viewing percentage. Okay, so the opacity is the, and here also I have create fig command ax equal to plt dot subplots. Then after that I'm gonna give three lines in here. Okay, so three lines, and first one is blue and second one is I have given this is the value for your hexa. Okay, some of them already know what is hexa values. So if you didn't know that, okay, you have to search hexa color in your website. Okay, and you can click the first one, color underscore or hyphen hex.com. Okay, you can pick the color and it shows the code with hash in front of it. You can copy that and you can paste in here. Okay, so the color which you have chosen will appear in your plots. Okay, and this is the hexa color code you can find in the bottom. Okay, okay, so you also use Google hexa color code. Okay, so RGB is for red, green, blue combination, right? And this is your Google color picker. Okay, you can track the lines. Okay, in the left side box, the color is changing, right? And also your RGB value and the hexa value also changes. Okay, so here first one is your hexa value and second is in your RGB value. You can use either hexa or RGB. From my suggestion, you can use hexa. That one is best. Okay, so you can easily get the exact color you have chosen it. Okay, in here I'm going to copy this color and I have to paste in here, right? So I'm going to run this. You can see the exact color will appear. Okay, so have appeared in here, right? You can use EXA values, you can use RGB values for giving color. Okay, so same AX dot plot, then after that your value X and Y value, then color. Okay, so you can mention blue or B, whatever. Then your EXA code also and your RGB code also. Okay, and we have cyan code. Okay, for colors. You can use EXA, right? The alpha is for opacity. Okay, they are giving 0.2. The blue is light. Okay, so here I'm giving 0. It won't, you can't see here because the opacity is 0. I'm going to give 8. It looks better, right? I'm going to give, say 8 is for 80%. Okay, so if you are giving 2, 2 is for 20%. It looks light, right? If you are giving 1 and that is 100%, you can see the exact blue with 100% opacity. Okay, is it clear?
Yes, sir.
Yeah.
Yes, sir.
Okay, so the next one is line and marker styles. So to change the line width, we can use the line width or LW keyword argument. Okay, the line style can be selected using the line style or LS keyword argument. Okay, so here first you need to create a subplot. Here I have used the fixed size for getting maximum size, that's all. And after that I have created a 4 plots, okay, with line signs of 25%, 50, 1, 2. Okay, you can here you can fix what size you want. Okay, it won't depends on 0 to 1. Okay, so you can mention to 0 0.25, 0 0.50 and 1, 2, and it depends on your width. Okay, then also you can give like this LW. Okay, and also you can mention line style like this. Okay, if you want to print like hyphens, you can give like this, and if you want to print hyphen and dot, you can give like this, and if you want to print colon, you can give like this. Okay, then custom dashes, that means, so first I have given line equal to ax dot plot and x value and x both xy value, and color is black, and w equal to 1.50. Okay, then after that I have a setter line equal line dot set dashes. Okay, so 5, 10, 15, 10. Okay, so first is line length and space length, right? And here you can see the black line and this one. This is your black, right? Then after that, possible marker symbols. Okay, you can use pluses, you can use O star S and commas, dots, 1, 2, 3. Okay, these are the marker basics. Marker means, and this is your marker. Okay, this is your marker. First, I have plotted a blue one. Okay, these are the marker types. 1, 2, 3 blue lines are marker types. Okay, first I have given plus. So plus is indicating here. Okay, so sorry for the dash is, yeah, so the custom dash is in here, the black one. Okay, the custom dash means one is shorter and another one is longer, and shorter, longer, look like this. Okay, then so your marker symbol plus O star S 1, 2, 3. Okay, so first they are giving plus, and star. Okay, so first they are giving plus and O S1, right? So plus, it look like it's pointing plus in here, and the next one is O. O is look like this. Okay, O with and the marker S. So S is look like your squares. Okay, and finally they are using 1. You can see the 1 here, right? The tiniest, tiny one here. Okay, and you can mark your dots. Okay, these are the marks are based on your value, x and y value. Okay, and then marker size and color. Marker size and color. So the final, the top 4 rows. Okay, so first one, they are indicating line color is purple. Okay, 4 lines are in purple color, and after that they are mentioned line style in dashes. So okay, so because they are using single dash. Okay, so the single dash means just a line. Okay, if you are giving double dashes, it looks like the blue first one. Okay, if you are giving single dash, it is just a line. Okay, then after they are giving O and S. Okay, so S is in top one, and the O second one O, then finally one more. Okay, so the first one is in here, and the second one is in here, and third one is in second one, and fourth one is first. Okay, they are defining their marker sizes. Okay, just a minute, guys.
Yes, sir.
So here you can see the marker sizes. First one is 2. So 2 looks tiny, and the 4 it looks bigger than 2, and the 8, and the final one is 8. Okay, so here they are mentioned. The final one is they have mentioned marker face color is yellow, and marker reg with this 3. Reg means the border. Okay, and the marker reg color is green. Okay, and the marker reg color means the final one, the final border color. Okay, so they have mentioned the reg, and they have mentioned the color is green. Okay, is it clear?
Yeah. Yes, sir.
Yeah.
Yes, sir.
Okay, so the last one is plot range. Okay, so plot range, we can configure the ranges of axis using the set ylim and set xlim. Okay, so the methods in the axis object or axis type. Type is for automatically getting tightly fitted axis ranges. Okay, so first one. So we have created a file. Okay, I have created subplots with 1 row and 3 columns, and fixes is 12 to 14. Okay, and then 12 is width and 4 is height. Okay, then after that I have created 2 axes. You can choose. We have 3 plots, right? You can choose the plot individually by using index position. If you are using 0, this is 0 plot, and this one is first plot, and this one is second plot. Okay, so, and the title they have given, and the values also. Okay, so then xlim, then ylim. So they have mentioned xlim and ylim for second one. This is Okay, this is second, because if you are not giving this xlim and ylim, okay, so this will overlap your first one. Okay, so you can see, so the spaces are different from your first one, second one. It okay, see here we have we get a little space here. Okay, if you don't give xlim and ylim, okay, then it will overlap those two plots. Okay, so the lim means range. Okay, so the plot range, that's all. Or you can use axis dot tight underscore layout, or axis of tight. You can use like this, or you can use axis dot tight underscore layout for getting evenly spaced plots. Okay, so then special plot types. There are many specialized plots we can create. Okay, such as bar plots, histograms, scatter plots, and much more. Most of these type of plots we will actually create using Seaborn. Okay, a statistical plotting library. We have one more library in data analysis, that is Seaborn, for creating histogram, bar plots, and scatter plots. Okay, so but here are few examples of these plots. Okay, so you can use scatter, plt.scatter, and it gives dotted bar, dotted plot. Okay, if you are giving hist, okay, here they have used data equal to sample. They have mentioned they have imported from random module. Okay, sample is for a sampled data, and it returns 100 values from 1 to 1000. Okay, it returns 100 sample data from 1 to 1000. Okay, you can see here these are the 100 values with decimal values. That's why they are using sample. And simple, same, plt.hist, then you can pass the data. The data only differs, and the method formats are same. If you want to use a scatter, you can give scatter instead of hist. Okay, this is your histogram. And then this is the box plot. Okay, this is the box plot. Okay, so we have more types. Okay, these three are sampled. Okay, so we'll see. We have a lot of types in Matplotlib. Okay, so we'll see in futures. Okay, so thank you all, and we don't have much time. Okay, so do practice, and that's all. Okay, so thank you all.
Thank you, sir.
Meet tomorrow. Bye.